All right, welcome everybody. We're looking at starting chapter 9, which is on polynomials, monomials, adding them, subtracting, multiplying, dividing. We're with really just a big piece of vocabulary here. So we've got 1, 2, 3, 4, 5, 6 words. So monomial, we're going to start out with is mono. Just like in English class, mono means one. So this is an expression with one term. Expression with one term. We've talked about terms before. So terms are anything that has to do with, it's like separated by a plus sign or a minus sign. So it's an example of that would be like 2x has one term, but 2x plus 3 has two terms. So here's one, here's the second one, so two terms there. So that's not a monomial. But we are going to use that example later. So another example might be something like 3x squared as a single term. It's a monomial. So binomial, again, bi means two, so this is an expression with two terms. With two terms. This is where that 2x plus 1 or 2x minus 1 comes in, whatever I said. I said 2x plus 3. So 2x plus 3. So you've got one term here, second term's there. And they are separated by a plus sign. It could also be a minus sign. Trinomial has three terms, still is an expression, so this has three terms. So it could be something like 2x squared plus 4x minus 7. And poly means many, so this has many terms. So it could be something like negative 3x to the third plus 4x squared minus 12x plus 1. An example of a polynomial. Now, one thing to really note here is that a binomial and a trinomial are also polynomials. So poly means many. So as long as you have 2, 3, 4, 5, 6, 7, 8, 9, 10 terms, it's considered a polynomial. However, a monomial is not considered a polynomial. The reason for that is many. Mono means one. One is not many. So that's the way that goes. Degree of polynomial. This is a way to kind of classify these also. So degree is the exponent that is largest. So for instance, the last one we did here was negative 3x to the third plus 4x squared minus 12x plus 1. That would be a third degree polynomial because you've got the biggest exponent is 3. Another example would be 4x to the fourth minus 5x. So that's a fourth degree polynomial because it has a 4 in it. It's the biggest exponent. All right, and lastly for our vocabulary is called the leading coefficient. And the leading coefficient is, when ordered correctly, it is the first coefficient. So the first, and a coefficient is the first number in front of a variable. In front of a variable. All right, so what that means is, let's say we have something like 3x to the third plus 4x to the fourth minus 7x squared plus 3. Now you look at it and say, okay, well the first number in front of a variable is this 3 right here. But that's not the leading coefficient. So you have to order them correctly. Whenever you order them, you always go from biggest power to smallest power. So in this case, we have 4x to the fourth plus 3x to the third minus 7x squared plus 3. So you see how this goes from 4 to 3 to 2 to nothing. So those are going in descending order. So our leading coefficient is this 4 right here because it is the biggest one. It is the coefficient in front of the biggest variable. All right, so if you need to take a second, you can take a second and make sure you write these down so you've got them. If you need to pause the video, you can go back, that's fine. If you need to rewind the video, that's fine also. But we're going to keep moving on, so I'll give you a second. Okay, So look at some classification things here. So we have 4x plus 2x squared minus 8. So is it a polynomial? Yes, it is. It is actually a trinomial because it has 3 terms. And what is its degree? Well, here's our biggest exponent. So this is a second degree. And its leading coefficient is 2. So 2 is the leading coefficient. So that's right here, that 2, leading coefficient. Okay, so the next one we've got, 4x, is it a polynomial? No, it is not a polynomial because it's a monomial. It's only got 1 term. What is its degree? It is a first degree. So remember there's that kind of imaginary 1 up there, so it's a first degree. And its leading coefficient is going to be 4. So 4 is the leading coefficient. Leading coefficient. All right. One more. Is it a polynomial? No. The reason why? It's not an expression. So expressions don't have equal signs. This is an equation. So no, it's an equation. All right, good. And equations don't have degrees, so you can't add that in. So there's nothing there for it. All right. So now we're going to look at how do you add or subtract these things together. And the big key thing for this is looking at making sure you use like terms. We talked about like terms before when we're solving equations, and we're going to use them again. So what I like to do when I first start out is I like to look at, I like to put boxes or circles around things or underline things with different colors for the like terms. So I like to start out with, okay, what's my first one here is a 4x to the third, and I've got a x to the third here, so I'm going to put boxes around those. I also have a x squared, and I've got an x squared over here, so there's a box around that. And then I have a 7x, which doesn't have anything with it, so it's kind of by itself. And lastly, I have a minus 5. So now let's start looking at going from biggest to smallest. So biggest to smallest, my biggest ones are my blue. So 4x to the third, 4x to the third, plus a positive x to the third. So that means I have 5x to the third. In my red is my next one, so I have a positive x squared plus a negative 3x squared, which means I have negative 2x squared. My next biggest is in the black, and that's just going to be a positive 7x, because there's nothing you're adding to. And then lastly, I have a minus 5. Doesn't really blend in very well, so I'm going to pick a different color for that. Let me just grab orange or something. So minus 5. Okay. And now let's set the plus one. Make sure that you are using that plus symbol each time you do that. So you're using that symbol in between them. Okay, so let's look at the next one. You've got 4z squared over here. And I've got a negative 2z squared. So when I do that, I've got this one minus that one. So 4z squared minus negative 2z squared. That's going to be a chop-chop, so we actually get 6z squared. Let's look at our 5z. So now we've got a 5z. Now we don't have any z's over on this left-hand side here, so no z's over here. No z's. So we actually have nothing, so 0z minus 5z, so we get minus 5z. And now we can take a look at our numbers. So we have a negative 3 minus a negative 1, so chop-chop on that. It gives us a minus 2. Oops, sorry, minus 2, not minus 3. All right, so we've got 2 more here for you. I want you to pause the video. I want you to try these 2 on your own, and then we're going to get back together, and we're going to do these all at the same time so you can have a chance to work through them on your own. So pause it, work through those 2, and we'll be right back. All right, so your top one there, you should have gotten 12x to the fourth plus 5x to the third minus 3x squared minus 1. So you have the 3x to the fourth and 9x to the fourth, which gives you the 12x to the fourth. Your 5x to the third is staying positive, so that becomes a positive 5x to the third. You have a negative 2x squared plus a negative x squared, which is negative 3x squared, and then a minus 1 at the end. And the last one, in orange, we've got a 11t to the fourth, which is positive on the right-hand side. Remember, there's none of them on the left, so you have 0t to the fourth minus 11t to the fourth, which gives you negative 11t to the fourth. So then we go to our t squared, so we have 3t squared plus 4t squared on the left-hand side. So that gives us 7t squared. We combine those two. And you're subtracting negative 3, which means you're adding 3, which gives you a 10t to the second. And then the last one there is the one in black, which just becomes a minus 5t. So negative 11t to the fourth plus 10t squared minus 5t. All right, that's all for today. Have a good night.